researchers, Confab and Dr. Nitesh, who has my close friend and who has referred me to get in touch with this. So I'm very happy to present my research work. This is a complete my research work which I started on saline water using solar photocatalysis. So I would like to share my screen. So are you seeing my?
Yes, it is visible.
Okay. So this research is especially, as you know, here in this part of world, and Gulf countries, water is very crucial one, and many desalination plants are working where to get the potable water from different sources, maybe from surface seawater or from groundwater. So Saudi Arabia is the leading in desalination plants. So the idea which I got in 2005 is before the seawater or any saline water enter into the main process, so there will be a pre-treatment process to remove the pollutants. So that maybe conventional treatments, chemical methods will be used to remove the trace pollutants, because these trace pollutants will when enter into the main plant. So the main plant objective is to remove the salts and get the water, but these trace pollutants will create a problem in membrane clogging, biofouling, as well as the scaling formation, both in thermal process and RO process. So what I felt in 2005 is, why can't we replace the conventional process with photocatalysis process? So keeping in that in mind, I started my work application of the solar photocatalysis, especially first with natural artificial light we used, and then we went for the solar light. So to treat the water, saline water especially, and then remove the pollutants so that the water can be directly fed to the desalination plant. So where the impact on fouling and the scaling formation will reduce. So that is the basic idea of this research. So this research I started in 2005 in Oman, where I worked there for 18 years. And then I shifted to Saudi in 2020. So before that, I worked in India also. So in industry as well as in teaching academic field. So are you able to see my next slide? So actually, this photocatalysis is the pioneer is Professor Fujishima. He started this in 1967 when he worked in his laboratory, where he used his titanium dioxide sheet and put it in water, and then he observed there is a splitting of water to produce renewable energy. But at that time, he published it in Nature, but at that time, the conversion efficiency is only 0.3%. And he felt that this may not be a good idea or a good what is called a technique to produce renewable energy, but produce the renewable from the water. So the photographs is playing a big role in producing the hydrogen and oxygen, but still commercial wise, it is not that much implemented, but laboratory wise, a lot of research is going on. The other aspect is using this advanced oxygen process in water treatments, where the trace pollutants can be removed. So it is just a technique similar to photocatalysis, means photosynthesis, where we will absorb the light and green leaves and produce oxygen from CO2. Here, the light is absorbed by the photocatalyst, and it can split the water molecule to hydrogen and oxygen. So it's a very simple, when you take a small particle, nanoparticle of photocatalyst, it is bombarded with a light source, whether it's artificial or UV light. The excitation of electrons takes place from conduction band to valency band to conduction band, and then the positive holes will form in valency band. So these positive holes will react with the water molecules to produce hydroxyl radicals. So these hydroxyl radicals are highly reactive in nature, and they can react with any organic, inorganic, or even metals in a trace quantity, and then it can produce the final product is only the water and carbon dioxide. So, and at the top, the electrons which are going to this the conduction band, they are absorbed by the oxygen molecule and it becomes superoxides. And that oxygen and superoxides also very powerful reducing agents. So both are powerful reducing agent to oxidize the pollutants in a trace quantities. And this has to be happen in picoseconds. Otherwise, recombination of the electrons and hydrogen will take place. So the three different methods we can apply to contact the aqueous water solution with catalyst. It can be put it in a batch mode, or it can put it in suspension circulation mode, or it can put it in a thin film mode. So all these three methods we have worked and we have achieved a good result. So this is the first work which I carried out with my student, undergraduate student. Is a girl student and a very good student in Oman in 2006. So she has coated the photocatalyst in a small glass tubes, and then she used the degradation of benzoic acid present in water, and she has produced her thesis. So this is the first work, and it has been published in a journal also. And from there onwards, we are starting working on degradation of pollutants in water quantities. But all over the world, many people work on photocatalysis, but work using photocatalysis for saline water is a big challenge, because many people work on normal water or even the municipal treated water. We also worked on it. But saline water, the big problem is because of high salinity, because of high chlorides presence. These chlorides are the scavenging of hydroxyl radicals. So when chloride takes away the hydroxyl radicals are very limited for the other pollutants to degrade. So that is a big disadvantage when applying the photocatalysis for saline water, and it's a bit challenging one. So we have to suppress the chloride ions and also use these hydroxyl radicals to remove the pollutants present in water. And also the other problem is saline water is highly corrosive. If you use the normal type of pumps and piping systems, everything will get corroded. We all experienced that during our experimental studies. Only glass reactors and glass tubes, as well as the silicon tubes we have to use, so that we can study the experimental part. Otherwise, the pollutants that are present, which we measure in terms of COD, TOC and all, because of dissolution of this, the parts, the experimental parts, the TOC is increasing rather than decreasing. So we observed all this, and we took it as a challenge and work on it. And then which type of material is suitable for our experimental studies we have done. So we applied this photocatalysis for all types of waters: seawater, oil produced water, textile water, municipal water, refinery water, all these waste waters we have applied it, and we got a good results. But out of this, these first two, seawater and oil produced water, are very challenging because they are high saline in nature. Then so as I told, this is type batch studies we have done, taking a simple glass beaker and putting water and catalyst and exposed to sun, and with respect to the time, we observed how much the degradation is taking place. And also we have put it in a circulation manner with the glass tubes using peristatic pump, and the water is circulated and it is exposed to sun. And this is an innovative reactor system which we have used for internal circulation of catalyst as well as the seawater, and it is exposed to sun. The most difficult part is the coating of the catalyst inside the glass tube. That is a big challenge. That's why I got the patent here. So I have applied a new technology to coat the catalyst film, thin film. It is 1 mm, less than 1 mm on the inside the glass tube. Outside the glass tube, it is very easy. Even on a glass plate, is very easy to coat, to dip tube and all we can do. But inside a circular glass tube, to coat it is very challenging, and we have done it, and we produce the very good fine coated films. And also the problem is stability of the film. This film will get what is called peel off if the pH is more on acidic side. So we have to maintain the pH also to maintain the stability of the film. And this is one type of instrument which we have used to coat the film inside the glass tubes in a commercial manner. So I worked a big project sponsored by the Research Council in Oman. So seawater is having a lot of pollutants, especially the humic acid, which is a long chain hydrocarbons, And to break that humic acids, it requires a challenging aspects. But still, photocatalysis works on it and it breaks the long chains. And the final product will be water and carbon dioxide. So it is a very, very what is called very good technique where we won't produce any byproducts. So this is, if you see here, this is the coating of the films, and a very fine coating we have to do. And that film has to be stable when you are working on with water. So you can see the scanning microscope before coating and before treatment and after treatment. So this is before treatment, very fine catalytic surface you can see. And here after that, this little bit of abrasion is taking place in the film. QOC reduction we achieved now. Nowadays, this is old graphs. We achieved almost 70-80% removal by suppressing the chloride ions. If you don't suppress the chloride, we can reach up to 40 or maximum 45%. Reduction in COD, we almost reach up to 85%. So still the works are going on. Almost 3 PhDs has produced in this area. So I'm continuing the work, and we are applying the neural networks as well as the surface response to reduce the number of experiments to be done, and also to predict the output of the data and all those things. This is also the new 2 PhDs works are going on, and one is already awarded, the other one is going on. So this is my research team in Oman. All are these undergraduate students and PhD students, but in Saudi I have to take the picture with my students. So overall, this is a very good technique for removal of trace pollutants present in seawater. Many other techniques, adsorption technique, biological technique, many people are working on that. So we are working on the photocatalysis, that also on solar, using solar energy, which is abundantly available in Gulf countries. The one minor disadvantage here is the photocatalysis, which we are using, titanium dioxide is widely used. It is very active in UV range, but in a natural solar light, the UV range is only 5%. So we have to use the catalyst, which can be highly active in visible region. So for that, we have to modify the catalyst with some dopings and all those things, and we have to use those catalysts for the invisible region so that the efficiency of the process will be improved. So this is where we are working now. We have a new research project in collaboration with our Prince Mohammed University and Sultan Qaboos University, Oman. It's a huge project, international collaboration project, which we are working to develop the photocatalyst for visible region and apply it for the treatment of simultaneous treatment of water as well as production of renewable energy. So my postdoctoral work is also on simultaneous treatment of water and producing the hydrogen, where we are working now. And we started that research work, and let us see how we will achieve the goals. So this is my brief, as 10 minutes he has given, and so I reduced to it. So if anyone wants to be in contact with me, my mail ID is there. So you can see my ResearchGate, LinkedIn, everywhere. My profile is there. So we are open for collaborations, and also as a resource person for academics as well as research. So thank you very much. Once again, thank you very much for providing the opportunity by the organizers.